Alright, so we're going to try to solve the Dorian auto problem using LibreOffice Calc. And now the computer you're watching this on is a Linux, or the computer that I'm using is a Linux Ubuntu. So here's the problem statement. We talked about it in class. We're going to try to minimize the cost, which is 50x plus 100y, such that 7x plus 2y is greater than or equal to 28, and 2x plus 12y is greater than or equal to 24. And we want x and y to be positive numbers. Okay? And so just to be consistent with this, I'm going to start the solution down a little bit at 13, line 13, although you don't have to. So the idea here is I need space for my solution x and y, and I also need space for my cost functions, or my cost coefficients. So I'll say coefficients, because it's 50x plus 100y, right? And so down here is where I'm actually going to have my solution xy, and so these are going to be left blank for now because I don't have an x and y to start with. But the next line is going to be cost. And the cost is 50x plus 100y. So how are we going to compute that? Well, we're going to use something called sum product. And the idea with the sum product is that it takes two inputs, and then it's going to take the dot product. So sum product is actually a dot product, and so we're going to take the vector B14, C14, and B15, C15. We're going to dot those two vectors together. So I'm going to say B. I'm going to use dollar signs because these are, well, I don't really need them. Let's leave off the dollar signs. B14 to C14, just to make it simpler to see, and then B15 to C15. Okay, so that's going to be the dot product. Good. Next, we're going to have some cells for the constraints. And so here I'm just going to be putting down the coefficients. So the first coefficient, or the first constraint, was 7x plus 2y is greater than or equal to 28. So I'll say 7x and then 2 for the y, and then I'll just put in a reminder this is greater than or equal to, 28. Okay, and then the next constraint was 2x plus 12y was greater than or equal to 24. I'll just make that to look a little nicer. I'll squeeze this one down a little bit. Good. Okay. And then now we could also do that. We could also say that the constraint is that x is greater than 0 and y is greater than 0, but we don't really need to do that because it'll be taken care of in the solver. So I'll leave those blank. Now there were some other, let's see, I need to put in a couple of other. So notice that so far I haven't actually computed the constraints, so that's what I'm going to do now. So I'll just say left-hand side here, right-hand side for my two constraints. So this constraint is my first constraint. It's going to be another sum product. And how am I going to actually compute my constraint? The dot product is between my solution xy and the cost coefficient 7, 2. So the xy is coming from B15, C15 again. So B15, C15. And then the second set of constraints is, or the coefficients for the constraints, are 7 and 2, which is B18, C18. Good. Now, I need a semicolon there. Good, there we go. Okay, now I can just put in my right-hand side here if I want to. That's cell E18, right? Okay, and then, 18. Okay, then the left-hand side for this one is going to be the same. Now, notice if I copy this, if I just say edit, copy, and then paste, what happens is that I get B16 and B19, right? But I didn't want the first one to move. So the way to get the first cells not to move is to put a dollar sign around them. So in this expression, I'm going to say this is dollar sign, dollar sign, dollar sign, oops, dollar sign, dollar sign, there we go. Okay, so this is telling the system not to change the top one. So now what happens if I copy this now and I paste it down here? Do you see that the B15, C15 didn't change now? But the B19, C19 went down one row to get these coefficients. Good. So now those are all set. And now we have equals cell E19, I think, right? Good. Okay, now everything is set up. So what are we trying to do here? Let's take a look at our solver now. Tools, solver, and let's see what things we have here. So we're going to optimize the result to a minimum, and it's going to be by changing, let's see, the target cell. Where's my target cell? My target cell is the cost function, right? So that's B16. Let's say B16 is my target, and that should be the minimum by changing cells here, B15 and C15. Well, we could put a semicolon there, although there's just two numbers. Okay, good. And then my limiting conditions are, the cell reference here is going to be B22, right? And then this is going to be B23. And I want this to be greater than or equal to, then I could put in the cell references C22 and C23. Good. Now this is all ready. Now I need to hit the options because we want to also say that we have positive numbers. So we see some things here. Assume variables as non-negative. There it is right there. So if you hit that, you could keep the limit branch and bound fine. It's fine. Say OK. And now we say solve. The result is 320. And notice that we got that by taking x to be 3.6 and y to be 1.4. And so we'll say yes, we'll keep that result. And now you've got your solution. Good. So again, how did we find this solution? Once you have these positions or these cells laid out, right? What cells do you need for the solver? The solver needs a cell for the target, and then it also needs cells for the constraints, right? So then so it's actually, let me say that again. You need cells for the target, you need cells for the x and y, your decision variables, and then you also need cells for your two constraints, or however many constraints you have. Good. All right, so that is the solution. Try it out and see what happens, either with Excel or LibreOffice Calc. I should say Excel is pretty much the same thing. I don't have a copy of Excel on this computer, but I'll try to find one, and then I'll try to post the solution to that. All right, I'll talk to you in class, or at least later. Bye.